Okay, so the simple questions are, what is a mole, and how does it apply to the periodic table? The simple question. It's on page 10, where it says moles. And you guys, you can watch this video too if you ever get stuck on what a mole is. It's a nice refresher. Believe me, it takes a long time to start feeling comfortable with this number. So I give you some hints on how to be comfortable with this number. Okay, it's on the page 11. So here are some hints to get comfortable with what a mole is, what the number actually is. So one thing you could do is you could tattoo 6.022 times 10 to the 23rd on your wrist, like so.
We have that. Your wrist is different.
Do you get extra credit if you tattoo it on your wrist? Yeah.
Really?
Really?
I'll tell my mom.
Okay, do that. She'll love that. You could go to bed each night rehearsing the definition, 6.022 times 10 to the 23rd, 6.022 times 10 to the 23rd. It's a sleep aid. You could also write the definition on a dry erase marker on the mirror at home and look at it every time you look in the mirror, which for some people is a lot. What else? Write the definition on every cover of every book you own, but if you don't read, then it doesn't really help you. Text the definition to friends and confuse them and make you feel smarter.
What?
Text the definition. Text 6.022 times 10 to the 23rd to somebody, and they'll be like, huh? You're like, oh yeah, I know what that means. You could rename your cat. This is my favorite one. Rename your cat 6.022 times 10 to the 23rd. Get off the couch 6.022 times 10 to the 23rd. Stop vomiting 6.022 times 10 to the 23rd. Stop scratching that. You're getting my pants all hairy. Yeah. 6.022 times 10 to the 23rd. Find Mr. Nangle and tell him this definition until he tells you to stop bothering him.
Okay.
That's the last one.
You definitely have something against Mr. Nangle now.
I've got nothing against Mr. Nangle. Okay, some other things that make you just feel more comfortable with this definition is to just write this in the explanation/rule box. This helps me. Every time I see this, it kind of like, it just reminds me that this is just a number. That's all it is. It's just a number. So a pair, I like to write this down. One pair, and then I write an equal sign. One pair equals 2, right? Then I write 1 dozen. That equals 12. Good. 12. And I'm just going to write 2 things. 12 things. Right? It could be 12 donuts. It could be 12 shoes. It could be 12 anything. And then I say 1 mole. 1 mole is just, it's just this. It's just 6.022 times 10 to the 23rd. That's it. Things.
Oh, that's a good comparison.
That's it. That's all it is. It's just things. It's a number of things. A mole of things. Right? So if you have...
If I went in and said, can I have a mole of donuts, like what would they
a mole of donuts, they would look at you cross-eyed. Unless they took this class and they would say, oh, we don't have, there's no way we could give you a mole of donuts.
They'd probably be like a dozen of it. No, a mole.
No, excuse me. I said a mole.
I want to take that more chocolate top and make it.
I said...
I hated that part. I love that part.
1, 2, 3,
It's so gross.
Mole.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's it. That's how many things. Guess how much that is. If we can make this in the...
Sextillion.
Oh my God. How'd you know that so quickly?
Yeah.
Hey, how'd you know that so quickly? That's 1,000 right there. That's 1,000,000 right there. That's 1 billion. That's 1 trillion. That's a quadrillion. That's a quintillion. That's a sextillion. So this is 602 sextillion things.
Can I have that many dollars?
There's not enough currency printed for you to have of that much. Yeah, right. There's
In
no
the
way.
world, there's not that much.
No. National debt for the U.S. goes up to where the 1,000, 1,000,000, 1 billion, something in the trillion. I think we're getting up to like 3 trillion or something like that.
No, it's like
10 trillion?
It's like 4, 5.5.
Really? Wow. Okay, so that's a lot of money that we owe.
Ooh.
To China.
What happens if you don't pay to them?
Well, all the economy collapses and we go into probably a depression and maybe wars and stuff. That's not a good thing.
How do we even owe them that much? Like, why don't we have when we order things pay them?
Oh.
Everything you make comes.
I don't get it.
They buy. Well, it's a complicated thing that I don't even understand. Actually, that's why I'm just saying it's complicated because I haven't looked it up. So it's because basically what I understand is that we've. And this is going to be funny. It's going to go on YouTube. But Mr. Sane doesn't know about the economy.
That's why you're a scientist.
Yeah. So there we go. It's what I understand is that they bought our debt from us. So we owe money to other countries for making things and sending them to us. And
Why would they pay for us? So we're
Because then
for
they make
your
money
indebted.
just to pay
Yes, that we have to pay them back with.
so they're betting on the fact that we're going to. So they basically they're buying stock in the U.S. government, assuming that we're going to increase in value over time, so that way they make money off of us. So that's why they own our debt.
If we all live like hippies, like there'll be no problems in the world.
Yeah, there would be.
All right,
Done.
The biggest problem is like
we all live like hippies. There'd be no problems. Right.
Done. You probably will.
Nikki's gonna watch this and be like, "What is he talking about?" All right,
All
so
men become part of
let's get back to chemistry, shall we? Yeah. So the periodic table is crazy because it's got something in it that it was right underneath our noses and we didn't even know it. This is crazy. Guess what? There's little numbers in the periodic table. Like if you flip to the first page in the workbook, it says like you look at the H, and then underneath the H it says 1.0079.
That's
Right?
the mass, yeah.
Guess what? This number is so awesome. This number tells you
The mass
the mass of 1 mole of H atoms.
Wait, that's crazy. Wait, but that's so.
What? This is amazing! Oh my god, it was right there. 1 mole of H atoms. So if you take this many H atoms, hydrogen atoms, and you stack them up one by one, just imagine that.
You'll actually feel.
You'll feel a weight after a long time. You'll feel that weight. It'll be 1.0079 grams.
but they don't even know what each atoms feel like or look like or
I know, it's been deduced. Kind of look the same way you guys just figured out how many
No, that's what.
grains of rice are right there. Okay? Originally, where is it? Oh, here it is. Here's a sample. So, here's a sample of 12.011 grams of carbon. That's it right there.
Wait,
Okay?
what?
So how many carbon atoms are in that container? You can tell me now.
That's a mole?
Mole
12.01.
times 12. A mole times 12.
What? Mole times 12.
No, can you say it again? Yeah, you said that.
I said, let me just say what I said before. There's 12.011 grams of carbon right there.
Alright, so you
So
divide
that would
a mole by 12.011.
So how many atoms do I have in that container?
A mole. One
No,
mole.
you have.
He's right.
What?
Yeah, like what?
Liters.
There's 1 mole of carbon atoms in it. So there's 6.022 times 10 to the 23rd atoms of carbon right there.
Is there actually?
Actually, yeah.
What?
I know. It blows my mind too.
Listen,
Yeah.
How did we for people, how did they come up with a math? Like, they didn't connect it with moles yet, they just all had moles.
No, what we did is well, it turns out to be that that's the weight of those atoms, okay? If the way that we came up with that number is we said, okay, we measured out 1 gram of hydrogen, okay, and we just, from there you can deduce how many atoms are in that, and then you can say, oh, well, that must mean that there's this many atoms of hydrogens there. So you can figure it out kind of backwards, through a backwards method that way.
How can you tell?
You can tell how much space those hydrogen atoms take up. Okay, so with that, you can see the mass of the hydrogen atoms. Yeah?
The which one came first, knowing a mole, and then you found the mass, or did you found the mass?
You found the mass first, and then you say what the
You
mole is.
realized it was a mole.
Yeah, yeah.
So
It's a handy unit. It's a handy unit for us so we can measure things. Okay? So the reason we even need to memorize the mole is just so we can do calculations in the real world. If we were on a smaller scale, we would probably define a different thing, not as a mole, but something else, I guess. And so we can do little calculations on like a smaller scale. But here on this large scale, 1 gram is a pretty handy unit. So that's why we use mole to show how many atoms there are for like 1 gram of carbon. Okay? That's kind of maybe. Okay, so that's it. Adon, looks like I lost you somewhere. Whoa, hello. You okay? All right, good. Now,
Can we have a quiz tomorrow?
quiz tomorrow?
Friday.
No, Friday.
Wait, aren't we already Thursday?
It's Wednesday.
It's Wednesday right now. Okay. Are you okay, Pauline? Let's look at page 12. Let's start off simple on page 12. I'm going to ease you into this. I know it's kind of weird. It's kind of difficult. Sometimes you just want to reject this and say, I don't want to believe in moles. I don't want to work with moles. But believe me, it starts to get pretty easy if you just start off slowly.
Where did the mole come from? Who comes up with
It's just a number. It's a number of things.
why that?
It's the number of atoms in 1 gram of hydrogen,
Why is it called
basically.
So that's why.
It's 1 gram right here. That's why we use the units of moles.
Why
Yes.
is it called a mole?
I think mole means pile in another language. So it's a pile. Cassandra Pauline.
Is there
Thank you. Is there what?
is there actual is there anything that has enough to be a mole besides atoms? Like, is there like actual things? Like, do you think there's a mole of something?
Electrons.
Yeah, but they're really, really small. Like, for instance, if you counted
No,
up...
but like actual like things that we use. Like, could you say like there's a mole of rats in the world?
No, you can't, because think about how many rats that'd be that many rats. There's not enough.
Ew.
We don't have enough. How many people do we have?
Oh, and there's only
in the
enough
world?
rats.
There's a mole
Like
with
billion.
blades of grass.
We have over 1 billion people.
We probably have moles of a mole of tables.
We have
Tables?
We have moles of
Imagine
moles of
how
grain
many
of sand.
tables. There's like 4
But a
tables
mole-
in this
We have
room.
moles of
Yeah,
grain of
there's more people.
What?
Yeah.
What about grains of sand?
Grains of sand, maybe we come close to that.
What about leaves?
Leaves in the world?
No,
Um,
No, like
probably
grass.
not.
Yeah,
Yeah,
they're big
so-
enough.
No,
Maybe
bigger
grass.
No,
Maybe
bigger
grass.
grass.
Sand.
Sand, yeah, like you said, like the number of grains of sand in the
There's probably
beach.
a couple
That's
of
why-
moles
yeah, that's why I
of
thought.
sand.
Yeah, I'd say that's about right. But if you want to get a sense of this, how big this number really is, it's so hard. Humans are really bad at figuring out what scales mean. I used to play this video called Powers of 10, where I'm sure you've seen this in like, Mr. Constance loves to show this.
Yes.
Where you take one person and you like zoom up on their hand and then you zoom out and you zoom out, the powers of 10, powers of 10. Every few seconds you go another power of 10.